Have you ever wondered if you can create an algebraic data type in Postgres and use it as a column type? If so, you're in the right place. Today we're diving into the world of Postgres and exploring how to work with these types. I totally get it. Trying to create complex data types can be tricky, especially when you encounter errors. You're not alone in this. Many developers face similar challenges when working with Postgres. Here's the specific question we're addressing today. A user asked, is it possible to create an algebraic data type in Postgres and then use it as a column type? They provided an example with types like hoofed and monkey, but ran into a syntax error. Sound familiar? Let's explore this together. So, what's going wrong here? The issue arises because Postgres does not support creating a union type directly from other types in the way the user attempted. Understanding this limitation is crucial for finding a workaround. And stick around. By the end of this video, I'll share a workaround that will allow you to achieve your goal of using complex types in your tables. To create an algebraic data type in Postgres, the user should first define the individual enum types. In this case, we will create two enum types, hoofed and monkey. Next, the user needs to create a composite type that can hold these enum types. However, Postgres does not support direct union types. Instead, we can create a single enum type that includes all possible values. Now that the user has defined the combined enum type, they can create a table that uses this type as a column. This allows for the storage of any of the defined animal types. Finally, the user can insert records into the zoo table. Each record can independently use the values defined in the animal enum type. To verify that everything is working correctly, the user can run a simple query to check the contents of the zoo table. Fun fact, the concept of algebraic data types comes from functional programming languages like Haskell. It's fascinating how these ideas have made their way into databases like Postgres. Now let's look at the answers provided by other users. An alternative approach provided by another user involves creating a function to define a new enum type in Postgres. This function allows you to pass the name of the new type and a list of existing enum types as arguments. After defining the function, you can create a new enum type called animal by selecting the function with the names of the existing types, hoofed and monkey. This will combine them into a single enum type. That wraps up that answer. Let's move on to another one. This user suggests that you are trying to merge two enum types in Postgres. They raise several important questions about your design, such as whether duplicates are allowed, if the design is static or dynamic, and how many enum types you want to merge. Assuming no duplicates and a static design, they propose using the built-in enum support function called enum range. This function retrieves an array of all elements from a given enum type, allowing you to create a new enum type that combines the two. That's all on that answer. Let's take a look at another one. An alternative approach suggests using domain types instead of enums for creating a union type in Postgres. This method involves defining a function to validate values against multiple domains. You can create domains for each animal type, like hoofed and monkey, and then define an animal domain that checks if the value belongs to either of these domains. However, remember that changing the base types requires manual constraint validation. Here's a pro tip. Always check the documentation for the latest features in Postgres. They frequently update their capabilities, and you might find new ways to achieve your goals. And there you have it. You now know how to work with algebraic data types in Postgres. Remember, understanding the limitations and finding creative solutions is key. If you found this video helpful, please subscribe for more tips and tricks.